Hey guys, this is CPM 3, Module 1, Lesson 3. And so we are going over section 9.5, which is formulas and problem solving. So objective A is to use formulas to solve problems. Tells you right here, a definition of a formula describes a known relationship among quantities. Many formulas are given as equations. For example, D equals R times T stands for the relationship of distance equals rate times time. So example 1, for the following problems, substitute the given values into each given formula and solve for the unknown variable. So in problem A, we are given this formula of S equals 4LW plus 2WH. And it tells me that S equals 102, L equals 7, and W equals 3. So substitute all of those in there. The only thing we don't know is H, and so that's what we will end up solving for. So my S equals 102, so 102 equals 4 times L is 7, times W, which is 3, plus 2 times W, which is 3 again, and then my H, which I don't know, so I'll just bring that down. So now just multiply. We can bring down our 102 equals, let's simplify this right here. So 4 times 7 times 3 equals 84. Plus 2 times 3 times H on this side here equals 6H. So now we just have a two-step problem. So let's subtract our 84 from both sides. So 102 minus 84 gives me 18. So 18 equals 6H. Divide both sides by 6. And my final answer is that H equals 3. So do that again over here. We've got A equals 1/2 H times B plus B. So you can do this two ways. I know a lot of times when we see this fraction here, we don't tend to like it. So if you want to, you can rewrite this as area equals H, big B plus little b all over 2. That's how you can rewrite that fraction right there. I think what most people are going to like to do though is change that to a decimal. So if you don't know what 1/2 is as a decimal in your calculator, you can just do 1 divided by 2, and that's going to give you 0.5, and so you can substitute that in. So I've got area equals 0.5 H B plus B, and that seems to make that 1/2 a lot easier to deal with as a decimal. We're told that A equals 60, so I've got 60 equals 0.5. I don't know what H is, so that's just going to come down. And then in parentheses, my big B is 7, plus my little b is 3. So order of operations tells me parentheses first. That means I've got 60 equals 0.5 H times 10, 3 plus 7. So now multiply. 0.5 times 10 is going to give me 5. So I've got 60 equals 5H. Okay, so again, what I did is 10 times 0.5 or 0.5 times 10, however you want to do that. And then divide both sides by 5. And we get H to equal, what is that? 12. Okay, so let's use that same kind of concept that we used with that 1/2 as an example 2. It says use the formula F equals 9/5C plus 32 to convert 14 degrees Fahrenheit to Celsius. So what this means is I need to substitute this 14 into F since it's 14 degrees Fahrenheit. So I've got 14 equals 9/5 C plus 32. Now we can easily solve this with that 9/5. But again, another way to write this, and maybe I should have done this before we even did this, is to convert this. When you do 9 divided by 5, we get 1.8, and so we can use that instead. So I've got F equals 1.8 C plus 32. Now let me make this very clear. When I use my calculator here, I don't have a calculator up there. When I use my calculator to do this, you get an even 1.8. Put it in your calculator. 9 divided by 5, 1.8. However, when you put in your calculator 5 divided by 9, which I thought I had a calculator on here, but I don't. Put that in your calculator and you get like 0.555, and it's just going to keep going with 5s, and then whenever your calculator stops, it's going to have a 6. This is something, a number like this right here, this is something you can't convert into a decimal. But when you put it in and you get an even 1.8, I'm not rounding, I'm not cutting off any numbers, that's when you can convert a fraction into a decimal. Okay, but if it keeps going and going and going, you can't use that. So just kind of keep that in mind. So we've already said that F is 14. So 14 equals 1.8 C plus 32. So again, you got a two-step equation. Let's solve for C. We're going to subtract that 32 over. So 14 minus 32 is going to give me a negative 18. And that equals 1.8 C. So I'm just going to rewrite that right up here. Negative 1.8 equals 1.8 C. We're going to divide both sides by that 1.8. And I get my C to be 10. So you can either say C equals 10, or you can say, and that should be negative 10, sorry. So you can either say C equals negative 10, or you can say negative 10 degrees Celsius. Okay. Either of those work just fine. So now we have some more word problem types. It says, Charles can afford enough fencing to enclose a rectangular garden with a perimeter of 140 feet. If the width of his garden is to be 30, find the length. So, easiest thing to do with these is to draw a picture. It says we have a rectangular garden. So here's my rectangular garden. I know my perimeter is 140, so P equals 140. It says the width of his garden is 30 feet. So I've got 30 feet here and 30 feet here. And so what I don't know is how many feet is this length. So to find the perimeter of any shape, you're just adding up the sides. So I've got X. No, we know what the perimeter is. Perimeter is 140, so 140 equals X plus 30 plus X plus 30. So just solve for X here. So I'm going to bring my 140 down, equals X plus X is 2X, and 30 plus 30 is 60. So to solve for X, we're going to subtract 60 over. Excuse me, those are my dogs. So 140 minus 60 is 80. So 80 equals 2X. Divide by 2. And we get X to be 40. And my unit here is feet. Now, typically word problems require word answers. So what is 40 feet? The length. So the length is 40 feet. Okay, example 4, the length of a rectangular sign is 2 feet less than 3 times its width. Find the dimension of the perimeter is 28 feet. So again, picture. We have another rectangular sign, and my perimeter is 28 feet. Now, when you read the sentence here, the length of the rectangular sign is 2 feet less than 3 times its width. This sentence right here. Which of these do we have no information about? The length or the width? I have no information about my width. So because we don't know anything about our width, that makes our width our starting point. That is my x. So this is x feet. This one here is x feet. So then how do I represent that the length is 2 feet less than 3 times the width? So 3 times the width would be 3x. But it's not just 3 times its width, it's 2 feet less than 3 times. So minus 2. And that's my feet. So now find the perimeter. So perimeter equals, so in this case 28 equals, add up all the sides. So 3x minus 2 plus x plus 3x minus 2 plus x. And again, that equals my 28 feet, my total perimeter. So solve, which means add your like terms first. We've got 3x plus x plus 3x plus x. 3 plus 1 is 4, plus 3 is 7, plus 1 is 8, so 8x. And then negative 2 minus 2 is a minus 4. So to get x by itself, we're going to add over 4. So 28 plus 4 is going to give me 32. So 32 equals 8x. So divide. And we get x to be 4. So what does it want us to find in this problem? In this problem, it wants us to find the dimension, and it's probably supposed to be dimensions, if the perimeter is 28 feet, so plug in. So I know my width is 4 feet. Okay, those are my widths. So plug in to find the length. We got 3 times x. X is 4 minus 2. 3 times 4 is 12. 12 minus 2 is 10. So these are 10 feet. 10 feet. And you can add this up. Is 10 plus 4 plus 10 plus 4, does that get me to this 28? Yes, it does. And so again, word problems require word answers. The rectangle is 4 feet by 10 feet. Okay, objective B, we're solving a formula for the variable. This is kind of the main part of this lesson. It says to solve a formula or an equation for a specific variable, we use the same steps as for solving for a linear equation, except that we treat the specific variable as the only variable of the equation. These steps are listed next. So, excuse me, multiply both sides to clear the equation of fractions if they appear. This one is optional, just so you guys know. You can usually solve these without doing that. Use distributive property. Simplify each side of the equation by combining like terms. Get all terms containing the specific variable on one side and all the terms on the other side, and then get the specific variable alone by using multiplication property of equality. Usually we're using that to divide. So we've got several examples. All of these, we got 6 here, 4 here, so 10 total, and then we'll have a word problem to end with. So example 5, for the following problem, solve each formula for the specific variable. So on A, I want to solve for A. This is kind of your formula for perimeter of a rectangle. You're adding up all 3 sides, but we're wanting to solve it for one of the sides. So treat this B and this C almost as a number. How do you get rid of a plus B? Well, opposite of plus B is a minus B. And so I'm going to subtract B to get it away from that side of the equation. But what we do to one side, what I'm doing over here, I have to do over here as well. So I'm going to subtract my B from the other side, which is just P. So can I combine a P and a B? Those are unlike terms, they're different variables. So it just becomes P minus B equals, and then what do we have left? I have an A plus a C. Well, I still haven't solved this for A. To get A by itself, and now get rid of that C. So the opposite of, again, a plus C is a minus C. So can I combine a C with a B or a P? No, so they just need to go side by side. We have P minus B minus C, and that is what my A equals. I think a lot of times these aren't very popular because this answer looks very unsatisfying. It's going to be just rearranging those letters. Just use your property of inequality to figure those out. On B, we have V equals 4 pi y. And I am wanting to solve this for y. Well, this one's actually a really nice one because it's just a one step. What is going on between 4 pi and y? Well, there's no operation sign, so that means they're all being multiplied. Opposite of multiplication is division. So we can divide this whole thing over. So I'm going to divide a 4 pi from both sides. My 4's cancel, my pi's cancel. I'm left with just y. Can I do any kind of combining, reducing anything here? No. So y equals V over 4 pi. So you can see a lot of these, you've got the exact same variables in here, it's just moving them around, okay? On C, we're wanting to solve this for K. Now again, this fraction really throws people off. It's a little bit easier for us to visualize this as D equals FK over 5. That little fraction bar just means divide. And so we can put that all over that 5. So when we do that, to get rid of that 5, we're going to multiply both sides. So 5 times D is 5D equals. Now remember on this one, when you multiply the right side by 5, it cancels this out here. So once it cancels, right, 5, this 5 divided by this 5 is 1. That's what makes it cancel. So don't multiply the top by what we're multiplying. That just kind of comes down since my 5's canceled. Now to get K by itself, what's going on between F and K? They're being multiplied. Opposite of that is division. So we're going to divide both sides by F. And so I get 5D over F equals K. Now D looks really complicated. You've got 2 pi RH plus 2 pi R squared. This is another one that's a real formula. This is your formula for surface area of a cylinder. Point is, we want to get H by itself. Now, I know we have a lot going on over here, but because none of those have an H, use that whole thing as a constant, okay? Think about this as if this formula was something like S equals 2H plus 2. If I had S equals 2H plus 2. To get H by itself, you would subtract 2 from both sides. You get S minus 2 equals 2H, and then you would divide both sides by 2. This is the same two-step problem. It's just got a lot more variables, so it doesn't look quite as pretty, but it's the exact same thing. So, to get this H by itself, I need to move this entire term over. So the opposite of a plus 2 pi R squared is a minus 2 pi R squared. So we're doing that to both sides. So that whole thing cancels, that whole term. I can't combine an S with a pi R squared. Those are unlike terms. So I've got S minus 2 pi R squared equals 2 pi RH. Okay, now this is kind of like this problem right here. What is going on between my 2, my pi, my R, and my H? Those are all being multiplied. So the opposite of multiplication is division. So because I'm wanting to solve this for H, we're going to divide everything over besides that H. So I'm dividing over a 2 pi R and dividing over here a 2 pi R. My 2's cancel, my pi's cancel, my R's cancel, and I'm left with H. Now, this one's also a very confusing one because a lot of times what we want to do is we see a 2 on the top and bottom, a pi on the top and bottom, and then take away an R. We cannot do that, because not only is that term being divided by a 2 pi R, but also this S is. I can't cancel out a 2, a pi, or an R with this S. So because we can't cancel those out, as ugly as this looks, this is your final answer. Okay, E. Now, E, and I think the next couple ones, this is really where we're about to go next module. And actually, yeah, next module. So we really want to get pretty good at these. This right here is considered standard form of a line. And we're going to end up rewriting this. So this one's really important to us in the future. I am wanting to solve this one for Y. So to get this Y by itself, I need to get rid of that X. So the opposite of a minus X is a positive X. So we're going to add over that X. So I'm left with Y equals. These are unlike terms. One has an X, one doesn't. So you can't combine them, just put them side by side. We get Y equals 13 plus X. Okay, same thing here for F. I'm solving this for Y. So to get Y by itself, I need to move this 3X. So this time the opposite of a positive 3X is a negative 3X. So I'm going to subtract that over. So I get Y equals, can I combine these? Is 7 minus 3X, does that give me 4X? No. These are unlike terms. One has an x, one doesn't. Because of that, you got to put them side by side. So 7 minus 3x is just simply 7 minus 3x. Last page, we got a couple more to do here. So 4x plus 3y equals negative 12, and I need to solve this for y. So to get this y by itself, I've first got to take care of this term and then that 3 in front. So opposite of a 4x is a negative 4x. So I'm left with 3y equals, can I combine a negative 12 and a negative 4x? No, one has an x and one does not. They're unlike terms, so they just need to go side by side. Negative 12 minus 4x. Now here's where the tricky thing comes in. To get this y by itself, we're dividing, and I think we're all good on that portion. But when I divide this left side by 3, what am I dividing on the right? Just the negative 12 or the negative 4x? Trick question, we're dividing both. So you'll see a lot of people just do like a divide by 3, and then they'll only end up dividing one thing, either the 12 by 3 or the 4 by 3. What I'm going to recommend is that you do everything individually over what you're dividing. That way we remember we're dividing everything by that. So I've got y equals negative 12 divided by 3 is negative 4. Negative 4 over 3, that doesn't reduce, so we can keep it as just negative 4/3 x. Okay, not pretty, but that is your answer. Same thing on h. We're solving for y. So, really the same as g. What's the opposite of a negative 6x? Positive 6x. So I'm left with a negative 3y. Don't forget this negative, that's right there in front of that 3. Equals, can I combine 18 plus 6x? No, that does not become 24x. So put them side by side. We get 18 plus 6x. And then to get y by itself, divide by negative 3. And I'm not just dividing one thing or the other by negative 3. We're dividing both of these by negative 3. So I've got y equals 18 divided by negative 3 is negative 6. And 6 divided by negative 3 is a negative 2. So negative 2x. Okay, on I think this was supposed to say 4y. And if it wasn't, we're changing it to it now. So, solving this for y. So, y minus a negative 7, I'm going to change that to a plus. So, I've got y plus 7 equals, I'm going to distribute over here. So, negative 5 times x is negative 5x. And negative 5 times a negative 3 is a positive 15. Now to get y by itself, I'm going to subtract the 7. So I get y equals negative 5x plus 8. Okay, and then lastly on J, we want to solve this for C. What I would recommend is changing this again. So, 9 divided by 5 is a nice even 1.8. So I got F equals 1.8C plus 32. So to get C by itself, we're going to subtract this 32 over. So I've got F minus 32 equals 1.8C. And then we're going to divide. Now on this one, it is true that both this F is getting divided by 1.8 and so is that 32. But you'll notice that doesn't really go into either one of those evenly. I don't think it goes into 32 evenly. Let me see. 32 divided by 1.8. No, it does not. So instead, we're just going to put this all over 1.8. So I've got C equals F minus 32 all over 1.8. All right, and then lastly, you will see one of these on your My Math Lab homework, and so that's why I've included this one on here. It says an architect designs a rectangular flower garden such that the width is exactly 2/3 the length. If 260 feet of antique picket fencing is used to enclose the garden, find the dimensions of the garden. So because we're talking about fencing here, that's talking about this outside portion, that is perimeter. So it's wanting you to know that the perimeter is 260 feet. So in this wording here, the width is exactly 2/3 the length. Which of those do you have no information about? That's going to be the length here. Okay, you know the width is 2/3 of the length, but I don't know anything about that length right now. So my length is X, and so they've already put that here for me, X feet. That's your starting point. So then how do you represent that the width is exactly 2/3 of this X length? That's going to look like 2/3 X. So then we have X feet up here and 2/3 X feet over here as well. So perimeter means add up all the sides. So I've got X plus 2/3 X plus X plus 2/3 X. And that equals my perimeter. My perimeter is 260. So combined, you can really add up all of these. They're all X's. But to kind of make it a little bit easier, X plus X is 2X. 2/3 X plus 2/3 X is 4/3 X. Okay, and that's what I found that a lot of people will do. But it's still like terms. Even though one's a whole number and one's a fraction, it's still X and it's still X. So go ahead and combine. So use your calculator for this. And if you don't know how to put this in your calculator, you can come and see me before class, after class, during class. But you need to know how to put this into your calculator so we don't have to do this by hand. But 2X plus 4/3 X is going to be 3 and 1/3 X, so equals 260. So again, I'm kind of skipping a step here. So if you need to know how to get from here to here, this is calculator work, you need to come and see me, okay? But we get 2/3 X, and then get X by itself, so then divide. So I'm going to divide by 3 1/3. And we're going to get X to equal, let me put this in my calculator. We're going to get 78 evenly. So it wants us to find the dimensions of the garden. So plug it in. So I know that my length here, my length is X, so my length is 78 feet. Okay, and my width was that 2/3 X. So we need to do 2/3 times 78. So calculator work again. And we get 52 feet. Okay, and you can check it, add them all up. Is 78 plus 52 plus 78 plus 52, does that give you 260? And yes, it should. So that's all I have for this lesson. Let me know if you have any questions. And of course, you guys can pause